Have you got an assignment, James?
Yes. Yes, Moneypenny. I'm to eliminate all free radicals.
Oh. Do be careful.
Radical equations aren't all that different from any other type of equation we've already studied. The only added challenge is to be able to isolate x, I'm going to have to eliminate the radical. For the first example we have here in radical equations, it's actually very, very simple. All I basically have to do is take each side and square it, because the operation of squaring is the inverse operation of square rooting, so those will undo each other and leave me with x equals 25. Now I could go back and check that in my original equation. If I take that 25 and I take the square root of it, the square root of 25 is 5, so that would check in that equation. Now the only added challenge when I have these radical equations is when the radical is not already isolated. Notice that if I try to just take the squares of both sides of this equation, what ends up happening is that I'll still have a radical on my left-hand side when I FOIL this out, and that's not really going to help me in solving. So just squaring both sides of a radical equation isn't the right way to go. What you really need to do before you square both sides, if we look at this same equation again, is I have to first isolate the radical so that I can take the squares of each side. So to isolate the radical in this equation, I'm going to add 3 to both sides. When I add 3 to both sides, what ends up happening is I get that radical by itself, and once I have that radical by itself, I can go ahead and square both sides to get rid of that radical. And what ends up happening is I get x is equal to 121, which is 11 squared. Now again, if I check this, the square root of 121 is 11, and 11 minus 3 is 8. Now you may have been able to eyeball those because those are very basic radical equations, but the process, when we have slightly more complicated ones, doesn't change at all. So for example, if I wanted to solve this for a particular value of x, the process doesn't change. So the first thing I'm going to do is isolate the radical. And to isolate the radical, I'm going to add x to both sides of this equation. When I add x to the left, it will cancel out. And on the right-hand side, I'll end up with x plus 2. So I've isolated the radical. And once you've isolated your radical, I can now undo what that radical does by squaring both sides of the equation. And by squaring both sides, the left-hand side will become just 2x plus 7. And the right-hand side I can FOIL, or I can use that perfect square pattern to expand it out. And notice that that radical is now eliminated. This is now basically just a quadratic equation. And if I rewrite it in standard form, I can solve it like any other quadratic. This one actually factors to x plus 3 times x minus 1, which tells me that x is either negative 3 or positive 1. However, the one catch of this method is that I do need to check these final answers. So watch what happens when I check. If I take negative 3 and I go to check it, so I'm going to check x equals negative 3 over here to the side, and where I'm checking it in is my original equation. When I plug in negative 3, I'll get the square root of 2 times negative 3 plus 7 minus negative 3 would be plus 3 equals 2. So I'm checking, is that true? Well, 2 times negative 3 is negative 6, and negative 6 plus 7 is just the square root of 1, plus 3 equals 2. Well, the square root of 1 is 1, 1 plus 3 is 4, and since 4 does not equal 2, negative 3 doesn't check, so that solution will be rejected. I'm also going to check the x equals 1, so if I take x equals 1, and I plug that into this equation, I'll end up with the square root of 2 times 1, which is 2, plus 7, minus 1 equals 2. And I'm checking that. 2 plus 7 is 9, and the square root of 9 is 3. So 3 minus 1 equals 2. And since 3 minus 1 is 2, 2 equals 2, that checks. So I actually only have one solution to this equation. So that's radical equations.
Radical! Yeah!
But in terms of what you need to do every time you have a radical equation is isolate the radical and eliminate it. And once you've done that, you end up with just a normal quadratic that you can solve with any of the 4 methods we've done: factoring, completing the square quadratic formula, or taking square roots. And once you've had that solution, check both of your answers or all of your answers and see which of those, if any, gets rejected and which you would keep.